Welcome to sampling distributions. So the idea here is that we want to look at sort of all of the possible things that could happen when we pick a sample. So recall that sample statistics depend on the sample. They vary from one sample to the next. So a sample statistic will vary from one sample to the next. So we essentially want to study what are all of the possible sample statistics that could occur from all of the possible samples. So again, if we have large enough populations, we often have thousands and thousands and thousands of possible samples to draw of a specific size. And so if we were to take every single possible one of those samples and then say find the average age from each sample, or find the percent who work full-time, or whatever it is, sample statistic it is we're studying, we will get lots of different values, and some will be more rare than others. And so we can kind of study what is common, what is rare, uh, just like we studied distributions of data earlier in the semester. So how it works, in theory, if we had the entire list of population data, we could actually find the, say, average or proportion for every single sample, and then just look at the spread of all that. So let's just do for a very small population and look at very small sample sizes, and we can see what the distribution would look like. So let's say that our population data is yes, yes, no, and we're just looking at uh, 3. So we just have our 3 data values in our set, and let's look at samples of size 2. Then our samples would be, oops, we could have yes and yes. So that's yes number 1 and yes number 2. We could have yes number 1 paired with a no. And we could have yes number 2 paired with a no. And those are my only possible samples of size 2 from that little teeny data set. Then if we look at the sample proportions, our p hats, if we're looking at the proportion of yeses, this first one is 2 out of 2, or 1. And then we have a 1 out of 2 and a 1 half. So our distribution here would be that 1/2 appears 2/3 of the time. So if we look at here, we can now pair this with our probability, just like we had for our probability distributions. So we had 3 things that could occur, two things that could occur. So 1 occurred with a probability of 1 out of 3, and 1/2 occurred with a probability of 2 out of 3. All right, 1 out of the 3 outcomes was a 1, and then 2 of the 3 outcomes was a 1/2. So here we're looking at, instead of what the actual data values are, we're looking at what the different sample proportions were. So we're going to do a simulation for this with much more data. So if we switch over, here's an applet. We're looking at Reese's Pieces. And in this case, let's say that we have half of the candies are orange, and let's just look at samples of size 25. So 25 candies in our sample. And then we'll just take one sample of 25 candies. So, and then we'll take the proportion. So here we can watch that sample being drawn. So in this sample, it looks like we had 14 orange candies out of our 25, and 14 over 25 is 0.56. So that's just one sample that occurred. We can do this again. And this time around, we had 13 out of 25. Go again. This time around, we had 12 out of 25 for a proportion of 0.48. Let's just do a couple more. Again, we had 13 out of 25. And 11 out of 25. Now, if I scroll down a little bit, there's a dot plot going on down here, which shows precisely those 5 proportions we just had. So now I'm going to do the same thing, but I'm going to let this run much faster. And let's go ahead, and instead of just doing one sample at a time, let's do another 95 so that we'll have a total of 100 samples of 25 candies drawn. And so the very last one I just drew was 12 out of 25 again. And then we have a dot plot down here, which has all of the different sample proportions, how many candies out of 25 that were orange from 100 different samples of 25. So we can already see sort of what are the common proportions to happen and what are more rare. Now let's go ahead and add a bunch more. So now we have 100 samples. Let's go ahead and add 400 more samples. And now our dot plot is much more intense. It's hard to distinguish the individual dots. And if you'll notice, this curve is looking to be our symmetric with a central peak or normal. So this is sort of our distribution of the sample proportions as opposed to a distribution of individual data values themselves. So this is just an introduction to sampling distribution.